Hello and welcome to another of PAVE's weekly virtual panels. My name is Ed Niedermeyer. I'm the communications director here at PAVE. I'm really pleased to be here and that you've joined us today. We have a really fascinating and very important and unfortunately often under-discussed topic to discuss today, and that is AI bias and the role it can potentially play in automated and autonomous vehicles. I'm really thrilled to have two wonderful experts here from our member companies to discuss this topic with us today. From Aptiv, we have platform function owner of HMI for autonomous driving, Nandita Mangal. Nandita, thank you for being here. And from Humanizing Autonomy, we have the co-founder and chief product officer, Leslie Nooteboom. Welcome.
Thanks for having us.
So I'd like to start with Leslie, and actually I'd like to take this opportunity to both sort of introduce the topic and also maybe introduce you a little bit and what you do at Humanizing Autonomy. So you know, who are you? What is it that you do? And sort of within that, you know, could you also explain just sort of what AI is sort of generally?
Yes, yeah, sure. So I'll start with the latter, right? So AI is basically artificial intelligence, intelligence that demonstrated by machines rather than people. I think in our specific use case for this talk, we should talk about it as a vehicle that can drive itself, preferably better than a human driver. And the main reason that people are worried about bias is because machine learning models, they might be a bit opaque in how they make their decisions, but for now, they're really essential in making those vehicles drive. And we're targeting something that we felt was really left behind by industry about 3 years ago, which is that these vehicles don't understand people. So we built a behavior AI platform that allows these vehicles to understand what people are doing and what they might be doing in the future, so that we can make sure that those vehicles are safer around people, can drive through urban environments just as safely as they can in areas where there are no people around. And that's the premise of humanizing autonomy. So making sure that these machines are built around the people rather than the people having to change themselves to be safe around the machines.
Absolutely. And Nandita, if you could sort of give a little background in the work that you do and perhaps use that to explain sort of the role that AI, or I guess the multiple roles that AI can play within the automated vehicle context.
Sure thing. So I'm the platform owner for HMI. And so anything HMI and user experience adaptive with regards to automated driving systems, especially the ADAS level 0 to level 2 plus systems, the interactions with the driver and the experience that you get inside the cabin. That's what I mostly work on at Aptiv. And I think the reason it's an exciting, very passionate work for me is because I feel like I'm designing safe human machine systems at the end of the day. So most of the work is focused on how does this driver or passengers inside the cabin interact with this complex system that we have built, and what are the dynamics that are brought in when we introduce automation inside the cabin. And from that perspective, as Leslie put it, our autonomous vehicles have to adapt to this very difficult real world that we have, that human drivers are very adept at driving and have a lot of contextual common sense knowledge. But we're trying to make autonomous vehicles also get to that bar. And hence, with artificial intelligence, just like a child, when he comes into this world, he needs to learn how the world works. We're applying the same concept over and over to autonomous vehicles. So there are different stacks, such as you have perception stacks, you have planning, prediction stacks, which help this car basically drive longitudinally, latitudinally, decide where to go. But if you think about it, car is not just about driving in a straight road, right? You're making decisions. You're also there, if there's semi-autonomous vehicles, you're involved in understanding what the drivers are up to. And if you have a co-pilot, a shotgun passenger sitting next to you, he would be like totally aware of the context and what this is a new city and hence you're driving this way kind of knowledge. But if you're just a machine trying to monitor this driver, how do you make that machine now all of a sudden have a lot of common sense context about how is this driver interacting with me as a system? How do we make sure I am able to learn this driver's behaviors and monitor him so that we are always in safe situations and don't end up in any unsafe situations, because at the end of the day, it's a safe critical system, same bar as, say, aviation or nuclear operators, where we have life on our hands. So the machine has to monitor the driver too and learn both inside the cabin and what's going outside the cabin.
Yeah. So I mean, what you both described, I mean, artificial intelligence is at just about every layer of the vehicle, both within the driving stack, but also how it's understanding and interacting what's going on inside with the occupants. That's a lot of responsibility, and so I think clearly the prospect that these systems could be biased is scary. Leslie, could you talk us through a little bit how AI bias can happen? What makes artificial intelligence vulnerable to bias?
Multiple things. So I think the two main ones that we worry about is in the performance of the models themselves. So you wouldn't want the models themselves to be biased and lack an understanding of a certain environment, a certain type of person, a certain type of behavior, but also in the application. So once you start relying on those models' outputs, you need to be aware that there can be bias in the interaction between how the people and the machine interact when they're put into the real world. So one interesting example that I can give on the models themselves side is when we had deployed our first platform, basically that was before e-scooters were around. So just to give you an example of the way that our software works, we understand what type of a road user someone is, we know where they are localized, and we have a prediction of where they're going to go and what behavior they might exhibit in the future. But our models had never seen e-scooters. So suddenly you had people who were standing still, not moving any part of their body, moving way faster than any person had ever done. And how do you predict that behavior? It was just impossible. So at that point, the models themselves informed us saying, hey, we're very uncertain about these types of situations. We don't know what's going on. And that triggered us to say, okay, wait a second. We need to train these models with e-scooter users as well, so that they start understanding it. But one part that's really essential that I mentioned is that these models told us about their uncertainty. And a lot of times, machine learning models are trained end to end. So basically, you take a whole bunch of data, you let the machine, the model figure out what the decisions are that it should make within coming to its final decision, but it doesn't provide you any insight in how that model made its decision. So what's really important is to make interpretable AI, at least explainable AI, so you can understand what's going on within that model. And luckily, we had done that from the beginning, because we first built our model for Western type applications, where we built in gestures that basically let these models understand what the road users wanted. But when we showed this to, for example, Japanese pedestrians, suddenly we realized that their gestures were completely different than the ones that we'd seen in London before. So that forced us to go a very modular way. So we built multiple models that interact with each other through probabilistic graphical networks, which basically means you can see how the network makes its decisions, which allows you to output uncertainty values, which in turn tells you how to detect bias, for example, and detect edge cases that you might want to add to your use case. So I think that's something really important to prevent the bias side of things, which is to understand how these systems make their decisions.
Yeah. Wow, that's fascinating. Nandita, are there some examples? I mean, I know there's some examples that have gotten a little bit more public attention. Is there one that jumps out to you as being sort of a particularly teachable moment in terms of helping people understand maybe not just AI bias itself and how it can happen, but maybe even what the impacts could be?
I think, yeah, I mean, you've seen since beginning of 2015, you started to see this trend where media started to highlight certain cases of, say, gender or racial bias, for example. And it's interesting because I think one thing to add is that we always will have bias. Bias does exist in our brains, right? Like we're humans and we like to think that we are rational logic beings, but we usually rely on our quick and simplified systems where we quickly have to make decisions to really get to a decision really fast. So we do have bias. And what we're, just to clarify, we're talking here about negative bias, right? Bias which actually negatively impacts a particular group of gender or race. So there have been instances where a particular group of, say, females have been impacted. And since artificial intelligence has been pretty prominent in, say, recommender systems, we see those examples come to light first, right? And what happens is usually this comes out in the media, and then there's a lot of quick remedy in the company to fix that, and then it kind of, which is a good thing, which is a good thing. You know, we need more of these discussions. So there were examples, for example, I think either with Google or Amazon, where females might be recommended low income jobs or jobs which were not as compared to males, high income jobs. And perhaps due to statistical data, there was bias in the data that was collected. And you would find as a woman perhaps not being recommended the same types of jobs, right? So this level of examples show that bias can exist very easily, because at the end of the day, it's not the machine learning AI that's biased. It's the developers who designed it in a certain way, gave certain annotations, labels to the data, and even sometimes they didn't realize that that bias existed, and it kind of percolated into the system. So I don't want to say bias is evil or very bad, like, you know, those developers didn't think, but there's so many different types of biases that can come into the system. And this was an example of, perhaps due to the fact of not having that check of bias, that statistical bias percolated into where recommender systems were showing different types of results to based on the gender you have.
Yeah, exactly. I mean, I think the whole, like, the developers being aware of the biases is essential. Like building these types of global technologies without having a diverse team is just not something that should be possible, even because you won't have the different perspectives of different type of cultures, different type of behaviors, without having a team that developed the technology that's aware of those differences, because you would just get pigeonholed in your view of how the world should be, which is not realistic if you want to deploy that technology worldwide. So yeah, I fully agree with that.
Yeah, that's a really interesting point. I mean, it seems, I mean, and you know, one of the really insidious things about any form of bias really is that, you know, it most often is unconscious or subconscious, right? People, or at least it's not recognized. What are some of the things, and Leslie, we'll start with you, but I'd like to get both of your thoughts. So you mentioned sort of having a diverse team. That seems like a really important structural piece of it. Are there other ways that you can, you know, have a better chance of catching a bias in your system, maybe even before it goes in the real world, or is like a certain amount of it always just going to be, you know, you kind of have to put it out there and see what it does before you can really catch?
Certainly, I mean, definitely. So on top of the diversity of the team, what you need to make sure is that you don't blindly trust the data. So, and I nearly see it as risk management, where you basically do these, we do these creative sessions with the entire company each month, where we throw challenges towards the whole team. So like marketing, engineers, research, everything's involved. And some of these sessions are around, okay, what are the risks of making this technology real? And what if we would be wildly successful? If we would provide this human layer for all vehicles in the entire world, what would go wrong? And we had sessions about, what if people want to take our technology and use it for a harmful purpose? What would happen? So that basically allows you to think about, okay, so yes, we're developing this model with a finite set of data, with a finite set of situations. But if you're aware of the risks that are additional to what you originally expected that software to be deployed in, then you can still mitigate a lot of those risks by building in like safety valves, basically, in how a software would react in a certain situation, even though it has never seen that data before. So I think that's something really important. So that's kind of like continuous testing and learning also after you've deployed. Because if you expect people not to change their behavior, for example, after you've put a car in a city and it's going to drive around for 10 years, well, I can tell you it's not going to happen. People are going to learn how that car behaves, so they might even bully it, as you've seen in the trials in Silicon Valley. You'll have new types of mobility, new types of behaviors, maybe even new types of clothing that makes it impossible to detect the person. So it needs to be continuously learning additional to your risk mitigation in advance.
That's really interesting. Go ahead, Nandita.
Yeah, I think that I completely agree with the litmus test that Leslie put together with, you're actually looking out for potential misuse or abuse of the system, which is an extremely important change in attitude, right? Going from perhaps defensive attitude to actually going out and testing your model iteratively throughout various phases of, say, data collection and model, like the whole model being built. But I think another step add to that discussion is the diversity of team. You also get people who are social scientists, who are qualitative and quantitative researchers, who can actually help in you establishing, okay, how is this product actually going to be used? Who's the intended audience? What's the context? And what are the exact methodologies that we need to use to collect this data set, this initial qualitative data set, or when we get there into even the quantitative data set, like what is the actual insights that we need to give to the model creation team to make sure we're collecting the right type of data? Do we need to go back to the elderly demographic once again and retry our data set, retry the model with a particular demographic again? Again, the iterative reasoning mindset is very crucial in this regards. And we talked about diverse teams, but also the diversity of opinion is very important, where we actually include social scientists, UX researchers, and developers all in the same room to actively talk about this issue, just because it's not something that's out there in the open. Sometimes even when the model is out there in the open and getting tested, only then we might see a bias example come through. So we don't want to wait till all the way in the end of the game till we've already designed the whole system, the whole model, to find out that, and it's going to be very hard if we have done all these phases of data collection, model building, annotating, labeling, adding weights, and then in the real world, finding that there's a bias, backtracking that is a very hard problem.
Yeah. We have a number of questions actually from the audience. There seems to be a lot of curiosity about the diversity issue, and I know Nandita just mentioned that the diversity, right? It means a lot of different things, and kind of all of them are important. And Leslie, I know that you at Humanizing Autonomy really emphasize sort of bringing some of social sciences and things that aren't traditionally seen as a part of technological development. Talk about how you how, first of all, why you do that, right, and then how it strengthens you in these sorts of areas.
For sure. I mean, and additional to that, we also have like a gender balance that we have at 50-50% within the entire company and within even the engineering teams themselves on purpose. We also have we filed for the possibility to sponsor visas very early on in the company, so that we could basically gather a team of people from around the world rather than being limited to our own geography and our own way of thinking. So this has been in there from the start, and for the reason being that we want to be this global understanding of human people. How can you have a global understanding of human people if you don't have those people in your team? So it's just been essential to the company But I wanted to add to that really, which is to have a collaboration between different kind of stakeholders in society. So not only you thinking in your tech bubble, but engaging with government, with standardization bodies, with citizens' juries. So this is something I learned from the Information Commissioner's Office, which is the privacy protector in the UK, which is to actually go out, build groups of kind of feedback people, which will be affected by your technology. They're not your customers, they're not your users in some cases, but they are affected. So that's like people who are disabled. They're affected by your technology being deployed in the world. So you need to hear their voice, you need to hear their feedback. And that actually allows you to get a much broader understanding of how your technology might be used and what biases it might have in the future. So I think one really thing that I would really like to press in this platform is that data sharing is essential, because once you've got all these different organizations, not only the companies, but also the governments, the city authorities, basically anyone who has data on how these systems might or might not perform safely in the world, if that's all shared, just like it is with airplane accidents, then you would have a far better understanding of how a technology like this could be safely rolled out. And you have a testing mechanism, because you can use real world data to be able to test whether something that is newly to be deployed in a new environment would perform well in that environment. So I think there's a whole lot of communications challenges around deploying a technology that affects the world as intensely as this would.
Yeah. Nandita, I wanted to ask you about, since you really focus on the HMI piece of all of this, which again, I think is sort of underexamined as a, as a place where AI and AI bias can really be an issue. And, we've certainly seen, I think maybe one of the most high profile issues has been around facial recognition. And there's just kind of been a bunch of different things. Can you share maybe what you've learned from that as a regards your the work that you do on the?
Sure thing. So I think it's very important for us to, and I'll start maybe with an example where our understanding of what's ethical and what's not is actually a very big discussion that needs to be happened at the society level, for example, where we are okay with, for example, having an age bias with teenagers having high insurance rates, for example, because they're young and they might have been shown that it might have higher accident rate. But we're not okay applying the same concept to say in a city where in this particular area a lot of accidents happen. So if you live in that area, you'll get a high insurance rate, right? So even with facial recognition systems, it's easy to make it very superficial and say perfection and recognize everyone and recognize all the different races and recognize eyes open, etc. But the problem actually goes deeper, because as a face, you have a lot of emotions. You have emotions tied to different contexts. So while this machine is trying to learn what this driver is doing, and if he's sleepy, distracted, those are like the first bar, I guess. But if you go deeper into understanding the state of the driver and what actions he's trying to do inside the cabin, bias can very easily percolate. Like happy people are, I'm making hypothetical examples, but happy people or neutral faces might have low accidents, for example. There could be biases that can percolate easily based on our implicit bias of how people look like when they are paying attention versus when they're in argument and might be distracted. So I think with facial recognition and recognizing the face of the driver, it gets a bit complex as to understand the true state of that driver with internal monitoring. Also, the intended activity with autonomous systems can get biased, where you engage in a lot of non-driving related tasks, especially if there's automation inside the cabin. So of course, we're going to apply a lot of modeling and learning to that, to understand what are you really up to, and did you really intend to disengage the system just now? And so there's a lot of interactions that we can have, which need to be extremely well studied and have those checks, like Leslie put it, so that we make sure we're not incorrectly assuming that the driver is in a different state or is performing some different action based on, say, it's a woman and she has a low stature, and let that statistical data guide, oh, she must not be looking around carefully, or her scanning behavior might be limited, for example. So there are checks that we need to involve even inside the cabin to make sure that that data is very well rigorously looked upon. There are checks in place to make sure, and it's really tested.
One really famous example of what Nandita explained is the MIT research, right? Where they were trying to solve the trolley problem. Well, I can tell you that it didn't, but it did tell you that different cultures perceive these types of situations very differently and would basically demand different outcomes in their environment. So I think that's where your comment about the whole society becomes relevant, because if a society wants such an outcome or wants such an experience, then that needs to be possible, because otherwise it's not going to get accepted in that society.
Right. Yeah, we're not making this a perfect system, right? We're making it a system for our society, and that's the gap that we sometimes forget, that it's a system to be adaptive to us. And that's when, if it's an intelligent system and it's adaptive to us, then it's working for us. But if it's just a autonomous car that obeys all the rules and even inside the cabin, it might be perfect, but it might not work in the city traffic, or it might not be the adaptive system that we're trying to build.
Yeah, it seems like one of the implications of this is that sort of as, for example, level 4 vehicles, starting in one place, as they move to new locations, there is going to be a potentially a good deal of work, of retraining to do to make that change, right? And so I guess there's sort of a question there about sort of, how generalized can you make things? We actually have a question from CCAV, the Center for Connected Automated Vehicles in the UK. Leslie, I'm sure you're quite familiar with them, but they asked how much variance of the human form is required to have enough confidence that the perception engine will accurately identify a human. And it seems like, that's sort of depends on where you're expecting it to work, right?
Yeah, exactly. I mean, you can have thousands and thousands of hours of driving through London, but if you use that same data set to train a detection model in, let's say, the United Arab Emirates, then it's basically not going to be as good in detecting how people look there compared to how people look here. So that's why I was hammering down on the whole data side of things, because if a government can build a data set of a certain situation or of a certain environment, even if a city can generate data sets of certain things that only happen within that cities, then you can also perform tests on the technology that you want to deploy in that city. So that's why I would always recommend doing a test on real world data of the environment that you want to put your technology in. That will teach you about how you must tune your technology to be applicable to that situation. But oftentimes it's really difficult to get access to that data. So this is something where I really feel like some sort of global coalition of testing data sets would be incredible, because it would allow everyone to test the performance of their technology for those specific situations.
Yeah, absolutely. Well, we're just about out of time. I'm sorry. I'd actually, before we go though, I would, and we didn't prepare for this, so I don't mean to put you on the spot, but are there like resources that you would recommend if folks in the audience are curious to learn more about this? Obviously, there's only so much we can cover in 30 minutes. Where would you each sort of recommend that they go to try and learn more? Nandita?
So there's multiple efforts that have thankfully started in the last few years. So DARPA actually has a whole project called Explainable AI, which explains their take and approach. There's the IEEE newsletter, for example, that's on ethics and AI autonomous systems that has started. I think the good thing is that no longer, perhaps I would like to hope so, that there are these small group of people that are thinking about this problem, and big companies are actually releasing toolkits. Like I think there's IBM toolkit on this topic that we can read up on, and it describes how we can avoid or lessen the impact of bias in our models.
Yeah, and I just say Nandita's maybe too modest to say this, but she also has done panels on this discussion with the Women in Autonomy group, which are really excellent. I was very lucky to be able to be a small part of one of those with the Autonocast. So that would be another one that I would recommend. Leslie, what would you recommend?
I mean, there's a lot of interesting reports, like, for example, from CCAV, so the Center for Connected Automated Vehicles in the UK, published great reports about this type of topic. I think the work groups within the United Nations, the World Economic Forum, the European Commission, for example, about ethical AI, are also very relevant, and they have great conversations, publish reports about their conversations that are really thoughtful. So that's what I would recommend to read around the more governmental perspective on it. But then what I really appreciate is the opening up of data sets from, for example, Lyft, where they allow any company to test performance of their technology based on their data set. So you can at least compare the performance for that specific technology. So I'm hoping that those will merge, where you've got government also publishing these data sets. Obviously, there are privacy challenges on that end, but I'm sure that they can be overcome.
Absolutely. Well, thank you both so much for taking the time to discuss this. Again, really just fascinating topic. Could have probably gone on for hours more, but we appreciate the time that you were able to give. Nandita Mangal from Aptiv, thank you so much. And Leslie, I'm sorry, your last name.
That's fine.
Nooteboom, I'm sorry, from Humanizing Autonomy. As someone with a long last name, I should do better. I apologize. Thank you so much for both of you for taking the time to be here. Thank you so much to our audience as well for taking the time to learn more about this important topic. We'll actually try and grab a couple of the resources that Nandita and Leslie both mentioned just now and tweet them out. So go ahead and follow us at PAVE Campaign on Twitter, and we'll try and get those resources to you in case you want to learn more. Thank you so much, and we'll see you again next week.